Hello again, my name's Craig. If you watched my videos before, you'll know that I'm a door and window controls engineer. In some of my previous videos, I've taken apart window actuators. This time I want to take apart this door actuator. Now this is one that was taken from a building where this has failed. It's a fire door opener. So in the UK, your last exit door, your door to the street, is always a fire door. This gets fitted on the top of the door, at the head of the door, and if there's a smoke event inside the building, this opens the door, and it basically creates a smoke-free escape route. It lets people out. This one's failed. It's not opening the door properly. So I'm going to open it up, take a look inside, see if we can see what's gone wrong with it, and just have a look at how it's built. I've never actually taken one of these apart, so this will be the first for me as well. Now we'll have a look at this, but we would never fix one of these. If this has failed, especially if it's a gear failure or a motor that's going weak, you would never attempt to repair on this and put it back into service. You need these things to work every time, so that if there is a real fire, a real smoke event, this is going to save people's lives. And if you've fixed a unit and you're not 100% sure that it's going to be reliable, you just wouldn't put it back into service. So I'm going to strip this down, have a look at it. So let's just get right into it. I've mentioned this tip before. When you're taking something apart, use an ice cube tray, and when you're taking it apart, put your screws in left to right. It's up to you. I normally put them in left to right, top to bottom, the same way you would read. And that way, when you're putting the thing back together, you would start down here and take your screws out and put it back together. And it means that you're not likely to lose any screws or put any screws back in the wrong place. These are all the same length, so they can all go in the same pot. Okay, and there's one screw here that's different. I'm not going to take that out right away, just in case it's holding something else together inside, and it maybe not designed to come apart like that. Okay, let's see if I can find my spudger. Box of junk. Maybe a bit heavy for a spudger, really. There we go. Right, clearly this side isn't as easy. It's not budging at all, and I think it might be connected to the gearing in some way. There's just no play on that at all. Okay, let's focus on this side then, because I can get this out. That's a 24 volt label. You get these on all 24 volt equipment, but still, the number of times that you see equipment that's in and it's been connected to the mains and it's burnt out, despite the fact that it's got that label on it. Okay, now you probably can't see that, and this will probably mess up the focus, but there's a circuit board down there, but it's about here. It's almost halfway down, so I don't think that's going to slide out quite happily. I'm pretty sure this is an extruded aluminium case, and it's got a channel inside, and then there's another extruded aluminium section in there, so it looks like it slides out, but it looks like it slides out from this end. So I think I'll take that last screw out, I'll loosen it anyway and see if that will free anything up. Okay, so that's a bit shorter. So I'll put a little mark on there, just to remind me that that's the short screw. Okay, I think I need to get something heavier into this. Like an old flat bladed screwdriver. See if that does the job. Okay, a bit of movement now. There we go. It's a milled piece of aluminium. Inside here, and now that this is open, there's just a big gear, and I can't see any of the drive yet. I can see the big tooth drive down below it, but I can't see any more of the workings yet, so I'll see if we can get this out. I'm just going to pause. I'm going to go and knock this out, try and do it without damaging it. Okay, that's the actuator apart. I'll just clean up some of the grease. It was a bit more difficult than I expected. I had to use a couple of hammers, and I completed it with the pole for a sunshade. Effectively, this came out first. It came out quite easily. Then this part here, this is the gearing. That's just a spacer effectively, but this part inside slides away up there. It's connected. The gears are connected to this here internally, and then this spacer sits in at the end. So effectively, just had to pull this out one end, and the rest of it knocked out the other end. So get rid of this. It's just an empty case. It's obviously shaped at one end for the business end for the motor. This bit's just an aluminium spacer, so I'll move that out of the way, and we're left with these two parts. Okay, now part way through the disassembly, there's a couple of bits, there's a couple of shims here. They're just washers, and I think it's to space these out. These are spaced flush on this side, recessed on this side, so I think they're just in there to stop it moving. Okay, so when I started to take it apart, the arm became free, like so. I think it goes on that way. Yeah, so the arm, that's now engaged, and the gears, and you can see there's quite a bit of gearing involved here. Part of the reason for that is there's a little motor in this end. You can see the back of it here. That motor, it's a 24 volt, I think it's 1 amp motor, but this door arm applies 600 newtons of force, so it does that through the gearing, because there's no way you'd get that anywhere near that sort of force directly from that motor. the motor spins pretty fast, and then effectively the gears reduce the speed and they create the torque. You can see that's why there's quite a number of them. Starts off up here. Let's see if I can take this cover off. Okay, that cover has the PCB integrated. Okay, let's see if we can pull the motor connections off. I don't think they have any locks on them. Okay, so that's free. We'll have a look at the PCB in a while, but there you are, there's the motor. That's quite a long motor. It's quite a, let's see what it says. Fine Technic. So that's probably a German brand. There's a stamp. There's a stamp there. It looks like a P with a circle, a bit like the Pinterest logo, but not sure if that, I'm not familiar with that brand. I mean, these are designed never to be seen, so they can put any brand in there they want, it doesn't really matter. There is a little bit of gunk inside. Let's see if I can pull it off. This is one of the problems you get. So this is looks like a piece of grass. I'm pretty sure that's what it is. You get that in these actuators because you've got a motor that's connected eventually to a door or a window. There usually are openings in them for the gears to go through, and it means that stuff can get inside, and that's quite often what happens, especially with the chain drives. You get a build up of just crud on the chain, and it eventually contaminates the grease, and the grease becomes abrasive. On the windows that get used for natural ventilation, so comfort ventilation, they get a lot more use. So because they're open more, they accrue more crud, and then when they drive back in, they take that into the grease, and they tend to fail quicker than the smoke vent motors. Smoke vent motors get driven hopefully twice a year when they get tested, maybe more often than that if it's in a school when they're getting tested, but you want that to be working when you need it to save your life, so hopefully it doesn't get driven too often and get too much crud in it. This, I guess, is about, I think this building was about 12 years old, maybe 11 years old, so for that and that amount of crud in 10 to 12 years, that's pretty good. It's pretty damn, it's pretty damn impressive. The amount of machining that's gone into all these parts, and these are all, I mean, they're likely designed quite some time ago. These have been in use for a long time, but the same unit's on sale today, and it looks exactly the same. So I would imagine that they put it together. They've maybe made some revisions to the board. It's likely that there's different firmware on the board, maybe some new features. Obviously these are the smaller, the high speed gears, low torque, but as it steps up, once you get to here, then these are the first sort of big tooth ones, if you like. You'll be starting to transfer to, there's more torque than speed, so these are all bearing seated, and then once you get into these ones, yeah, these are all bearings, just a different type of bearing. It's a, looks like a, well, they're all sealed obviously, but yeah, need to ask someone like Eve about the bearings. But that's all pretty robust, that's all pretty interesting. There's a lot more gearing in these than there is in the chain drives. The chain drives have a few gears, and they're mostly plastic. Certainly the one drive gear on the chain drives is plastic. In fact, the one drive gear on this is brass onto a plastic cog. See, that's similar to the chain drives. And I guess the reason for that is you need a failure point, because if something's going to give, you need to make sure it's something that's going to fail in a controlled manner. Okay, so that was actually quite simple to get out. There's just a couple of little indents on the board. that trap the device. Okay, so this board is heavily lacquered. Like I said, the case has got holes in it, so these things are exposed to the atmosphere, and they get damp and they get crud in them. So the last thing you want is your control board to get so crudded up that it fails. So it looks like there's power in here. This little board has a couple of other features. If you look at the cable, it's got a multi-pin cable, and you've got brown and white cores are the power, so they drive the unit in and out. And then you've got 3 other cores. These are, I believe, relay cores, so they're normally open and normally closed, and I think they can actually be, I think you can fire 24 volts through the relay. Now what these are used for is door locks. Because this is mounted on a door. If you've got a door entry system that locks the door, you need to be able to open that lock if there's a smoke event, because this will open the door, and if you open it against a lock, it deadlocks and potentially people could be trapped. So these cores here are used where you've got a simple lock. In most cases these are driven by a control panel. That control panel will then be linked to the door entry system control panel, so the 2 control panels will take care of the lock and the motor. But if you've got a very simple system where there is no control panel for your door entry, then you can run the lock voltage through these. I don't know what the colours are. You'll have a common, a normally open and a normally closed, so that the voltage will go through the common, and if it's a fail safe lock, so i.e. if when the power goes off the door's open, it will go through one set, and if it's a fail secure, it will go through the other set. There will be an element of programmability to this. Most of these you can connect up a programmer and make some changes. I don't know the detail of this one because it's not a manufacturer that I'm familiar with, but there will be some settings stored on here. So for example, the length of travel, the speed, the force that are used there, they'll be stored in here likely. And also if there are options for outputting voltage through the door lock, they'll be stored on here. But the basic functions are: power comes in, power drives up to the motor, so it will unlock the lock through the relay, it will drive the motor, and then it will continue driving until up the end here you've got a little sensor. This is a Hall effect sensor. Now this, when the board sits in place, it sits on here, and on the back of the one drive gear there's a ferrite disc. This will be magnetic, this disc, and I don't think I can't spin this, there's far too much tension through the gear set, I'll never be able to do that. But effectively this is a polarised disc, so it's got a magnetic field on there, and as it rotates, this little sensor picks up the rotation and it can tell how many rotations, and the chip will calculate what that means in terms of transferred angle to the door. So it basically speeds up and slows down depending on where it is in the arc. You don't want it running full tilt when it gets to the closing point, because if someone traps their fingers, if someone puts their fingers in the door, you want it to reduce its speed and its force as it gets towards the closing point, so that you limit the damage you would do to someone's hand. And again, at the other end of the travel, you want it to slow down before it reaches the end of its travel, so that you don't slam a door into a wall potentially or knock someone over. And that's it. There aren't any repairable parts on here. I can't see anything that's failed. The little capacitor looks okay. None of the gears appear to have any significant damage on them. Certainly nothing that would explain why this actuator failed. So no, I can't see anything at all. There's nothing caught in it. There's no detritus that's big enough that would lock up the gears that I can see. So it leaves the motor as the likely suspect. I can't actually get this motor out without getting the gears off, so I need to knock these last gears out, you know, knock the pins out. I'm not going to do that, but what I will do is I'll fire up the power supply and we'll see if the motor actually runs. So I've set the power supply to 24 volts at 1 amp max, and let's fire it up and see what happens. Careful to keep my fingers away from any moving parts. So you can see the worm drive's moving, it's rotating pretty fast. This gear's rotating pretty fast, and as it gets down through, by the time you get to here, the motion's pretty slow in comparison. So let's see if I can hook this up to the drive and see if it will go through its full range of motion. Okay. Okay, so you see the teeth jumped out there because the drive didn't know it was reaching the end of its travel, because I've just hooked up straight to the motor. But that would have slowed down. I'll put the board back on and see how it reacts with the board on. It could be the board that's got a failure. So now I'm reversing the polarity on the power supply, and that will drive the arm in the opposite direction. I've put this back together briefly, just to test the circuit board, just to see if that's potentially what's wrong. Doesn't matter which way around I put these are designed to drive in both directions, and you do that by reversing polarity. So I've put the board back in, I've pushed the little Hall effect sensor in so that it's next to the gear with the magnetic core on it. And this power's applied and it's not driving. Yeah, it looks like, I'll just flip this and see if I can get that sensor in the right place. Yeah, I can feel it pulsing every now and again. There's a little burst of power, as if it wants to move, but it looks like the board's failed. I'll just flip the polarity on that. Getting nothing at all. So the power supply is on at 24 volts. It's pulling 0.04 amps, so it's not doing much at all. Okay, so PCB's failed, so that's fairly straightforward, and you can't fix these. You wouldn't fix something like this. As I said, it's a life safety system, so you wouldn't put it back into service after a repair like that, because you don't know what else is going to fail. Apart from this being a surface mount board, it's got a heavy coat of lacquer on it, so even if you wanted to, even if you could see a component that was burnt out, the chances of successfully changing a component out on there are very, very slim, so you just wouldn't do that. Okay, so I'm going to admit defeat. I can't get this motor out without completely destroying the gear case. I could do that, but I know that the control board's failed, so I know the failure point's here. It is likely that the motor has got some wear on the bearings. It was quite noisy, it's pretty chatty when it was running, but like I say, there's no benefit to taking that off because I know that the controls failed. However, one thing I did notice when I was trying to get the motor out, see this gear here? It's toothed onto this gear with a fine tooth, and then the big tooth's toothed onto this one, and that's how it drives through. It's got a spring. It's the only one with a spring. None of the bigger ones have it. And I suspect this is I suspect that it's a clutch, if you like, so that if someone does try and force this will maybe jump, and it breaks when it jumps over here. The door is free of the door arm would be free of the motor. It's quite likely that this is designed so that this will jump out, and once it jumps out, it will basically sit on the tooth and wait to be rotated back in, like so. And that will be designed so that it doesn't break teeth whenever someone actually forces this door. If somebody kicks the door when it's open, or forces the arm when it's closed, hopefully this will jump and snap over rather than break any teeth off. So while I'm sitting here looking at this, I'm thinking, what could I do with it? I could actually replace this failed control board with an Arduino. I've got Arduinos kicking about everywhere that I've got for various projects. I've got some little Arduino boards that I've built other projects on, so I could effectively replace this with an Arduino, still have the Hall effect sensor on, or I could use some of these limit switches and have a very basic door control, but it would just be a project for playing about with, and I've got a massive list of projects that I would like to do, I'd like to attempt, so the chances are this is going to end up in the recycling. It's very, very likely. I hope you did learn something. Like I say, I learned a bit because I've never had one of these open before, and I'm not a YouTuber as such. I don't make a living from YouTube. There's no income from it. If you want to subscribe. I might post another video. It might be a year before I post another video, but I would like to post some more. So if you like to subscribe, fair enough. There's no Patreon or any of that nonsense, but you know, if you do subscribe, I'll see you in the next video. Bye for now.